Hello my dear NSEC aspirants. I welcome you to NEET World. I hope your preparation is going well, and in this particular session I am going to discuss few important questions that were asked in the previous NSEC papers. Okay, so look at here. An ideal gas reaction equilibrium is represented like A plus B gives rise to C plus D, considering the fact that all the components are ideal and that only AB are present initially. Which are the following options always true at equilibrium, where N represents the number of moles of species. Okay, so look at here, the given reaction indicated as A plus B is in equilibrium with C plus D right now. So initially they have said that at time t0 initially they are saying only AB are present. Okay, so if AB are present, if I say like C is a concentration of A and B also having C as a concentration, initially concentration of this product is 0 right now. So after some time t, what happens, some of these reactants converts into products, right? So at equilibrium we are going to have concentration something like this, C minus C alpha here, and this is also C minus C alpha. So why I am taking C minus C alpha? See, alpha is a degree of dissociation of this particular component to form this product, and C is the amount of concentration that is converted into product. So the amount of product formed here is C alpha, here also C alpha. So which are the following options always true at equilibrium? See, always true at equilibrium. Tell me what are the options here true? See, if I add C minus C alpha plus C minus C alpha, see they are saying NC is equals to Na. So this concentration and this concentration they are saying they are equal. Is that true? Yeah, may or may not be true. Okay, but they are saying it has to be always true. So may not be always true, at some particular point it may be true, but not all the time right now. Okay, so but if you observe C alpha, the concentration of C and concentration of D are having same value. See, this is also having C alpha and it is also having C alpha. This can be true at all the cases, at all the times, which means the perfect answer for this question will be option C right now. Hope this is clear what I have explained here right now. So number of moles of number of moles of this product C and D can be equal because both of them having same value, right? C alpha. So I can say this will be the most correct answer is C here, right? Yeah, let us move forward with few more questions here. Yeah, so for 1 mole of van der Waals gas with B is equals to 0 and the plot of PV versus 1 by V at 298 Kelvin gives an intercept of 24.4 liter atm Kelvin per mole. The slope of minus 2.5 liter square atm mole inverse square, the value of van der Waals constant A is. So just write the van der Waals equation first for real gases. P plus A, like for n moles we are taking P plus A by V square into V minus B. This is for 1 mole right now. For n moles here n square and here n you are taking, that is equals to RT. Right now if it is n moles nRT, they are saying for 1 mole you can take it like this, right? Yeah, so now they are saying here the value of B here it is 0, right? So you can write P plus A by V square into V will be equals to RT, right? So just multiply this V inside so that you will get PV plus A by V is equals to RT right now. So up to here it is clear, I hope. Next, they are saying that they have drawn a plot of PV versus 1 by V. Okay, so it means I can write PV is equals to RT minus A by V plus RT I can write. Right now if I send this side we will get like this. So it is something like, so PV is a Y, let us say, and here minus A into 1 by V plus RT we have now. So now here what I can say, PV is on Y axis, okay. So M X plus C graph we can expect from here right now. So try to draw that graph. So you can have like this. Here you can put PV on y axis, on x axis you just take it as 1 by V. Okay, so and after this what about your slope? Slope is negative but intercept is positive. So intercept is positive with slope is negative. It means something like this you are going to get. Okay, so slope is negative and intercept, this is the intercept, that is RT you have, and slope M here it is minus A. Okay, so what is your A value here? So slope, they are saying that minus 2.5 liter square ATM by mole square. So minus A is equals to minus 2.5 liter square ATM mole power minus 2, right now. So minus minus you can remove. So A will be how much? 2.5 liter square ATM per mole square. So you have option number 4 as your answer for this particular question, right? So I hope this is also clear, right? Let us move forward with few more questions. Yeah, look at here, the IUPAC name for the given complex. This is from coordination complexes, right? See, we have a 2 coordination spheres here. So cationic sphere, anionic sphere. In the both places we have coordination complexes only. Okay, so whenever you have 2 complexes, first write the name of cationic sphere, then followed by name of anionic sphere. Something like if you have NaCl, how we are calling this? So first we are calling like we are saying the name of cation, then followed by anion, like sodium chloride. Right now here also cationic sphere position first, the next anionic sphere complex. Okay, so now first of all, in order to write the name, you need to know what is in here, what is the name of water in the case of the terminology used here, and what is this OX. See, ene means ethylene diamine they are saying, OX means oxalate they are saying. So ene is a neutral ligand, therefore the charge with respect to ene will be 0, and water is also a neutral ligand, charge with respect to that also 0. And what about oxalate? Oxalate is a like bidentate with a -2 charge now. So it is having -2 charge, means with respect to that metal should have +2 charge, right now. So how many oxalates are there here? 3. Okay, see, if you observe what is the metal here attached here, Rm, like gold I can say. Right now in the both spheres it is gold only. Now you need to identify the oxidation states of these both metal atoms here. Since here if you see the independent cationic sphere, so it will be having 0 oxidation state, but completing all together you are going to get a +3 oxidation state for this, because here gold cannot make here oxalate are there now. How many are there? 3 are there, each one will be -2. It means -6 is the charge with respect to these oxalates, right now. So oxalate, so but +6 cannot be kept on one Rm itself now, so that will be distributed equally. So by taking +3 in both of these metal atoms. So here +3 and here also +3, right? Okay, so now write the name of the given compound. So what is the name here? First write the name of the ligands here. We have aqua molecules and ethylene diamine. Okay, which comes first? Aqua, right? So 2 are there. 2 means like diaqua, so you can write diaqua. Okay, and after that ethylene diamine. Already di is a term used in the name itself now. So now you can use bis. In the case of complex ligands, you just use bis, diaqua, bis ethylene diamine, okay, bis ethylene diamine. Next here like Rm, like gold is there now with +3, which is in which is in having positive cationic sphere position, right? So when the complex is in cationic sphere position, the ligand should be written like this, and whatever the metal is there, you just write it as normal name like gold here. So Au means gold now, you can just write it as gold. Okay, so diaqua bis ethylene diamine, gold. Okay, and you can write 3 oxidation state. Okay, and close the bracket. Okay, and after this you have the name of the other complex here. So oxalates are 3 now, so what you should write here? Trioxalato. Oxalato. Why we are putting this? Whenever you have a ligand with a negative charge, the name of that ligand should end with O, like oxalato, chloride, chloro, like cyano, like that. Okay, next what is the name of this like AU here? You should say when metal having negatively charged sphere. So that should end, the name of that metal should end with 8. Like here you should say R8. So what I should try? Oxalato, R8. R8. And what is the oxidation state? 3. Write it in the parenthesis. That's it. This is how you should write. See, diaqua, bis ethylene diamine, gold 3, trioxalato R8. So fourth option will be a perfect answer for this particular question, right? Yeah. So let me move forward with one more question. Yeah. Look at here, a chemical reaction X plus Y gives Z having following mechanism. These are the mechanistic steps they are saying. Okay. The overall equilibrium constant for the above reaction can be represented as. So for this particular reaction, how we can able to represent the equilibrium constant. Okay. So first take that X plus Y gives rise to Z. If I consider this as the equilibrium reaction, so I can say the Kc, the overall rate of this reaction, I can write concentration of Z by concentration of X multiplied with concentration of Y. Like this we can write. Okay. So after writing this, see, look at here. So just look at here. What I can write? So K1 by K2, which is equals to concentration of this XS by concentration of X into concentration of S. Like this we can write. Okay. And after writing this, so look what are the other steps you can able to write here. So for this K3 by K4, so you can write this K3 by K4, K4 equals to, so concentration of Z multiplied with concentration of S, okay, divided by, so S is a solid catalyst they are saying, okay. So this side we have Y multiplied with X minus S, okay, like this we can write. So now try to observe these two equations. Let us say this equation 1, 2 and 3. So how we got these equations? Completely from the given data. Okay. So try to multiply equation 2 and 3. So by multiplying equation 2 and 3, what we are going to get? Just check here. So I am taking here K1 by K2 multiplied with K3 by K4, which is equals to this multiplied with this. So concentration of XS by X into S multiplied with ZS by Y into X minus S. Okay, like this we have. Okay, so just remove those who can able to cancel out here and S. So what we are remaining here? So we have concentration of Z by concentration of X into concentration of Y. Okay, like this we are remaining with right now. So that is nothing but our Kc. So the overall rate of reaction constant, the equilibrium constant Kc equals to K1 by K2 into K3 by K4. That's it. Easy only, no? Yes, this is asked in the 2024 NSEC paper. So where do we have that option? So K1, K3 by K2, K4. So option number 2 will be your perfect answer for this particular question, right? Yeah. So next one more question here I have. Yeah. So this is a question. So just try to solve this question on your own, and I am going to explain this question in a short. Okay. So now consider it as a homework question as of now, and try to answer this question in the comment box, like whatever the option you are going to get. And if you are really facing difficult, just watch the short which I am going to make on this particular question. Okay. Yeah. So thanks for watching. Stay connected with us. And guys, if you are really interested for your NSEC preparation and looking for the support or mentorship, or you wanted to join our courses, okay, for NSEC Olympiads or NSEC, NSEB, NSEP, okay, IOQM, all these things are there, and NSEJs, if your any juniors are there, you can suggest them. And if you are really preparing for your NEET or JEE exams, you just contact to the mobile numbers given in the description box, okay, and can join with us and take your preparation to the next level. Okay. Okay, so thanks for watching, stay connected with us.